Hey, here's class number 23. It's on consumer debt, and it goes with section 10.4 in your textbook. And in our daily summary, in this lesson, we're going to explore the mathematics involved with finance charges for credit cards and the mathematics of installment loans, such as car loans and home mortgages. Keep in mind that project 3 is assigned now. And in our demo, we're going to start with a general credit card overview. All right, so credit cards can be a very useful financial tool. It allows the consumer to purchase items now, but pay for them at a later date. However, credit cards have a dark side. They can generate a massive amount of debt when used without proper care. And so here's how credit cards work. As long as you pay the balance due before the payment due date, everything you purchase is interest-free, means there's no finance charges. If you carry a revolving balance, which means you don't pay the full balance, but rather just the minimum payment or any amount less than the full balance, you're going to incur finance charges on the previous balance plus any new purchases made during the next billing cycle. This is key, not just on what you carried over, but anything else you purchased during that time period. Your next statement balance is then going to be your previous balance minus any payments you made, plus any new purchases, plus those finance charges. All right, number 2, the finance charge is based off of 2 pieces of information, the average daily balance and the periodic interest rate. Now, your periodic interest rate is the number of days in the month, so this can change depending on the month, divided by 365, and that's going to be multiplied by your annual percentage rate in decimal form. And your average daily balance, you're going to have to find the sum of all of your daily balances and then divide by the number of days in the month. Your finance charge then, you're going to take that periodic interest rate you just calculated above and multiply it by that average daily balance. And then your next statement's balance is going to be your previous balance, again, minus any of those payments, plus those new purchases, plus these finance charges. Okay, so do want to call your attention to that formula sheet that we've seen before. Note that last column on the right has these pieces we just looked at under credit card. So it reminds you of all 4 of those pieces. All right, so number 3, here's an example. Let's suppose you have a credit card with a 19.99% APR. And so notice these are going to be a lot bigger than what you typically see on savings accounts. The billing cycle starts on the 20th of every month and ends on the 19th of the next month. Suppose that so far you have been good about paying your balance in full each month, but at the end of November you had to do some Christmas shopping. So between November 20th and December 19th, you put $1,000 on your credit card for gifts, but when the bill comes, you can only afford to pay $300. This means you're going to carry forward a balance of $700 to the next billing cycle. Again, you had $1,000 on that card. You pay $300, that remaining $700 stays into the next billing cycle. All right, so in the next billing cycle, which goes from December 20th to January 19th, you make some more purchases. So you do some last minute Christmas shopping on December 23rd. So it's going to add $134.76 to your balance. January 1st, you go to CVS, you buy a couple of things, adds another $14.22 to your account, or your balance. January 10th, you got to get some gas for your car, so your balance is going to go up a little bit more. And then January 17th, you make a payment. Even though it doesn't close to the 19th, you do make a payment of $400. And anytime you have a chance, you want to make those payments as soon as you can. All right, so in part A, we're going to calculate the periodic interest rate for December 20th to January 19th. So remember, we want to take the number of days in the month divided by 365, so it's going to give us the fraction of the year for this billing period, and then multiply it by the APR in decimal form. All right, so in this case, you can count or double check, but between December 20th and January 19th, counting those 2 days, that's 31 days altogether. So that gives us 31 out of 365 days times our interest rate in decimal form. And that is a periodic interest rate, 0.016977. And I'm going to carry as many digits here as I can. Next up, we're going to calculate the average daily balance from December 20th to January 19th. And we're going to use this table to help us organize everything. So on December 20th, remember we had that balance of $700. We made a $300 payment. So it left us with a $700 balance. And we carried that through to the 22nd. And that's because on the 23rd, we made some more purchases. So on the 23rd, we bought $134.76 worth of goods, and that gives us a new balance of $834.76. And we carried that all the way through to December 31st. And that's because on January 1st, we did something else. So we used that card again, and this time we bought $14.22. I think we spent that at CVS. So our balance goes up to $848.98, and we carry that through to the next time we make a purchase. So on the 10th, we make a purchase. So that means that balance we just calculated is good through the 9th. On the 10th, we spend some more money. So we buy, what was it, $43.57 worth of gas. You can double check up above if you've forgotten. Gives us a new balance of $892.55. And we carry that through to the 16th, because on the 17th, we make a payment. So on the 17th, we make a payment of $400. So our balance is going to go down to $492.55. And that's going to stay on our account as our balance through the end of the billing period, which is the 19th. All right, so next step we want to do is figure out the number of days that has these balances. So for the first one, the 20th, the 21st, and the 22nd is a total of 3 days. The 23rd through the 31st is 9 days, and I'll leave it up to you to press pause so you can see why or verify that. January 1st through the 9th is 9 days. 10th through the 16th is 7 days. And just as another example, we've got 10, 11, 12, 13, 14, 15, 16. Those are 7 days. And then the last balance is on our credit card for 3 days. So a good check here. Remember, we knew that that was 31 days in the billing cycle. We should have a total in this column of 31 days. All right, our last step is we're going to get a product. So we're going to do 700 times 3. And it's going to give us a total of $2,100. And I'll explain why in just a moment. So we're going to multiply that next balance by 9 days, and it gives us a total of $7,512.84. Continuing on, do the next one times 9 days. Next one times 7. That's $6,247.85. And then the last one, we're taking this balance, and it's for 3 days. So over those 3 days, we have a total $1,477.65. And just as an aside, before we go any further, if we want our average daily balance, you're used to doing averages, or maybe you've done them in the past. Oops, we don't need an S on the end of that. Your average daily balance means we need to actually add up the balance from day 1, which was $700, plus the balance from day 2, plus the balance from day 3, plus the balance from day 4, which was the $834.76. And instead of writing out all 31, I'm just going to jump ahead and say those last 3 days, we had $492.55 as our balance. So we'd include that 3 times when we're adding up all these balances. And then we would divide that by the 31 days. Let's switch colors so you can see that. All right, so a shortcut. Instead of typing in $700 on your calculator 3 times, we're going to multiply 700 by 3 and just type in the product once. And as another example, instead of typing in that last balance 3 times, and we're going to multiply it by 3 and just type in its product once. So each of these numbers in the last column is the result of doing something very similar, taking the balance and multiplying it by the number of days that it happened or was on your credit card. All right, so our next step, we've got to find that sum. So grab a calculator, add up the numbers in this column. You're going to find that there's a total of 24,979.16. And our next step, we've got to divide by 31 to get our average daily balance. You should get an answer of $805.78. All right, so that is our average daily balance. So on average, that was our balance at the end of each day. Some were a little higher, some were a little bit lower. All right, next up, we've got to calculate our finance charge. So what are they going to charge us for carrying those balances? All right, so remember, we need to take the periodic interest rate. And multiply that by the average daily balance. Okay, so from up above, our average daily, let's start with the periodic interest rate. That was 0.016977. I think that's enough digits for now. Times our average daily balance of $805.78. And if you multiply that out, you should get an answer of $13.70. All right, if you use the more exact decimals, if you include a few more there, you might get a slightly different answer. So depending on how many digits you're using there, you might get $13.68. So if possible, and type in all the digits you have, or type in the expression that gave them to you. So type this in one more time, and then multiply that result by the $805.78. All right, so last step, part D, let's calculate your new balance that's going to appear on the bill for the next billing cycle. So remember, we've got our finance charge. I'm going to use the more exact value of $13.68 plus an ending balance. Go back up to your table to check this. We'll take a break, we'll do that. So up here is the last 3 days. Here is the end balance. How much was left on your credit card at the end of that period? Altogether, you're now going to owe a total of $506.23. So keep in mind, again, this piece here is your finance charge. And this piece here is your ending balance or previous balance. So you're getting charged about $14 because you didn't pay the credit card all at once. Let me make one more note here again. This is your next bill amount. Okay, number 4, an installment loan is the type of loan you would take out to finance the purchase of a big ticket item like a car or a house. These loans are different from credit card debt because the loan is for a fixed amount and is paid off in regular installments over a set period of time. The APR on an installment loan is generally lower than it is for a credit card, and the process of paying off a loan by making regular payments is called amortization. And so the following amortization formula gives the monthly payments M on a loan with principal P, an annual percentage rate R, and again, it should be in decimal form, and paid over T years. So again, here, notice T appears in more than one place, but this is number of years for your loan. So we've got another T here. R, again, is your interest rate, your annual percentage rate, and it has to be in decimal form. Notice it appears in 3 places in here. And this, your P, is your principal. So how much are you borrowing? How much does that car cost? How much does that house cost? And then lastly, this is going to give you your monthly payment. Right, and just like before, we've seen this before, but note that this may be different than other textbooks or your textbook. This is the way it's written in your formula sheet if you check. But your textbook, you may see it written like this. So we can move that over. Get a little bit more room. So M is equal to P, so that part's the same. And then in parentheses, instead of saying R over 12, you could do R over N. Maybe it's not monthly payments you're making. Maybe you're going to make 2 payments per year. So this way of writing the formula allows you to customize it a little bit more. Okay, the other difference, again, instead of doing it 12 times per year, you're just saying it's N times per year. So it appears in a lot of places. In that case, t is still the number of years. And it gives you one other way to write it that you may encounter. We're going to focus on the one in the box, but I do want to give you these other options in case you've seen them before. That lowercase p we've seen before. Okay, in this case, t is your number of payments. If you're doing it per month, it's the number of monthly payments. And p is equal to r over n. N is the number of payments per year. So again, we're focusing on this one, but I wanted to show you the other two in case you see this in another textbook or your textbook, or if MyMathLab pops up with a slightly different looking formula. All right, number 6, we're going to do an example. We're going to find the monthly payments on a car loan of $25,000 that has an interest rate of 2.99% over 4 years. So notice that is quite a bit smaller than what we just saw with the credit cards. All right, so we're looking for the monthly payments. So M is going to be our variable. The car costs $25,000, so this is what our principal is. And then in parentheses, our interest rate is 0.0299, and it has to be in decimal form. And we are doing monthly payments, so we can leave 12 in there. And we're going to fill in the rest. Top number is 48, and just a note that T is 4 years. So 12 times 4 is where that 48 comes from. In other words, you're going to be doing 48 payments over those 4 years. All right, that is all over 1 plus 0.0299 over 12. And that again is to the 48th power minus 1. All right, the biggest challenge here is being able to type this into your calculator. So again, the goal is to be able to type that in all at once with only hitting the equal sign once at the very end. So instead of intermediate steps, again, try and get in the habit of typing it in all at once. So I'm going to write down the answer here. And I'm going to have you press pause to try that out. And the key is being able to type that in all at once. If you can't do that and you need to do it in steps, keep as many digits as you can so that you get an exact answer at the end, or as close to exact as you can.